afternoon, everyone, and welcome to the 29th episode of MSME Masterclass. Today, we would like to introduce you to Mr. Dhruv Mittal, Managing Director of Syscon Wires. With nearly 3 decades of profound experience in the wire industry, Mr. Mittal is a visionary leader who has propelled Syscon Wires to its position as one of the top 3 leading manufacturers in the field of CHQ wires, alloy steel wires, and SAIP wires. Mr. Mittal's journey has been marked by a relentless pursuit of excellence and innovation. He identified critical gaps in conventional processes and recognized the imperative for consistent quality and decarb-free alloy steel wires. Determined to address challenging facing cold forging and end applications, Mr. Mittal embarked on a mission to redefine industry standards and mitigate losses in steel manufacturing. Please join me in extending a warm welcome to Mr. Dhruv Mittal, a trailblazer in the wire industry whose visionary leadership continues to shape the future of manufacturing. Welcome to MSME Masterclass, Dhruv.
Hi, Amrita. Thanks so much for such a wonderful introduction. I'm really very happy to be here at this place. And I think, thanks once again to JSW1 MSME, for organizing this wonderful webinar. I've been a big fan, huge fan, of times when, you don't get to meet people offline. This is a good way to get insight into what they're thinking, what's happening in the industry. I think it's a wonderful initiative. Totally love this series.
Thank you so much, Dhruv. Means a lot. Actually, we've had a lot of requests in the past, and we've also observed that the industry needs something like this to cater to their ever-growing needs, and especially for MSME. So that is the reason to conduct these masterclasses so that everybody can benefit from this. The topic for today is ideal wire for cold forging and fastener making. And before we delve deeper into the topic, I would like to ask you, Dhruv, because I know for a fact that Syscon Wires has forged strategic partnerships and implemented cutting-edge solutions, including leveraging annealing technology from Ebner, Austria. Could you please share with us some, details of how Syscon Wires functions, introduction about Syscon Wires as such?
Sure. So basically, Syscon Wires is situated near Mumbai in Khopoli. We are a small company doing niche wires, and we are basically into CHQ wires, which are used in automotive applications, bearings, and all the cold forging applications. So that is the core of what we specialize. And then from there on, we have expanded to various applications where the need for wire is very critical. Okay. More or less, the processes roll around spheroidized annealing, which is the heart of what we do. That's the core competency, or that's the core of everything we do at Syscon, and we deeply understand it. And we have devised products which, using technology and the right technology in place, which very well suit the end use and the application. And over a period of time, we have only refined it to a great level, and this pursuit is sort of endless right now, I feel like, and that's my obsession. And we are also looking at exports market recently, so I'm very happy that we're making products which are acceptable outside also.
That's amazing to hear that Syscon is doing so many things in terms of steel wires and cold forging and fastener making. So we'll move on to the first question that we have, Dhruv, which is what is cold forging and its significance in fastener manufacturing?
So if I were to explain, cold forging is basically material shaped, any sort of metal, when you try to shape it using localized compressive forces at room temperature. That's cold forging. That's like a one-liner definition. But if I were to talk in terms of a layman, say if you take a nail and if you keep hitting it with hammer over a period of time, and if you increase the intensity of the hammer, you will see the surface begins to flatten or D-shape. And the shape will begin to change. That step would be best put up as cold forging. Although cold forging is very sophisticated in fastener making and everything like that, basically this process does not involve the use of heat, and a lot of mechanical pressure is exerted to get a desired shape. That's cold forging for starters. Yeah.
Okay, and could you also explain to our audience the role of wire selection in cold forging process?
So basically, when we look at wire selection, first we have to look at the end use and the mechanical properties that we want in the end use. So are we able to find a chemical composition suiting the end use application? I think that is one of the most critical areas. On this basis, on once we do this, then there is a process route design for the wire and the product. So for the wire we are doing, for the process, for the part or the fastener manufacturer is doing. And all this is done keeping in mind the cost and performances, because based on the chemical composition and the end use, the number of processes are added or reduced, and costing is sort of worked out on these parameters. So I think it plays a very important role in terms of determining the efficiency also, because if you layer up 5 processes versus if you are able to finish it in 3 process and get the same desired result, I think that's very critical in selling fasteners. And same it gets to us, because everybody wants cost efficiency as a baseline.
So, Dhruv, could you also explain what are the common materials that are used in wire manufacturing for cold forging?
So if I were to talk about the common materials that are used in cold forging material, so the one is low carbon, which is starting from carbon 1006 to 1022. Then there is medium carbon, which also includes boron steel grades like 15B25, 10B21, 15B41. And then you have the alloy steel, which is 4140 EN8D 1541. And then high carbon and high carbon steel. High carbon steel has carbon starting from 51, 55 going up to 81, 85, 90, and then bearing steel grades also. So we are operating across all these grades, and besides that, there is stainless steel also, which is used for making stainless steel fasteners. We are not into stainless steel, but stainless steel fasteners is also increasing in India right now. And anybody looking at cold forging could also look at this space. It's highly export oriented. There's a large domestic market, and I think it'll grow in the times to come.
And if we had to move on to the next leg of the same question, which is with regards to how does the material composition affect the properties of the wire and the final product?
Steel making is a very, very complex process, and I think there are masters and metallurgists who design steel. But based on our understanding and our understanding of the customer segment, we look at a couple of things. So one we look at is the microstructure. So say if we have identified a grade, then we look at grain structure, grain size, because that will give the desired properties to the final product. So, and then we also look at magnetic properties of a material before before deciding on which grades to take. And then while we pick up any grade, we look at 6 elements. A lot of y'all would be knowing about this by the virtue of operating in steel, but for somebody who doesn't know, I will just quickly walk them through these 6 elements. So primarily it is, number one element is carbon. Like we all know, like it's the most important element of steel, and it provides tensile and hardness to the material. Okay. Second is we look at boron. So boron is when you want to increase the hardenability of material by adding very small quantity of boron in the material is added, and that provides you reliable hardenability. Plus, it also adds some resistance to corrosion. Okay. Third element we look at is chromium. So chromium is the one which provides resistance to corrosion as well as improves hardenability. And fourth element that is very critical is we look at moly. So moly helps in machinability. Fifth element, we look at manganese, which is improves formability, and nickel is the last element that improves the strength and hardness without affecting the ductility and the toughness. And a combination of these factors, along with the microstructure, have a very large impact on heat treatment, on the cycle, and things like that. And the outcome of that is just totally beautiful. When I look from my passion point of view, and that is what determines how it is going to be used in the end and how a certain grade will react. So these are some of the things that we and our customers look at steel selection. How we select steel.
if we had to categorize the mechanical properties for which are the crucial ones in cold forging when it comes to mechanical properties?
Okay, so when I'm talking about wires, I think I would like you to walk through about six properties. So number one that I feel is spheroidization. So spheroidization is, so say if my material is cracking at cold forging stage. So one of the reasons could be poor spheroidization. Okay, so spheroidization is the one which will provide you a good machinability. You can avoid line stoppages, and you can get a better tool life. So I think first and foremost is when we manufacture anything, we look at spheroidization at raw material as well as finished goods stage. Second, an equally important parameter is decarburization. Okay, so decarburizing is the process of removing carbon from the material. So imagine if the material was high carbon, if and if while heat treatment I'm removing the carbon, so it loses the essence. The material will just not be able to perform. Okay, say if I was doing making a product out of it, the edges won't be sharper. Say if a nut was made out of it, and the spanner will slip, just to give you an example. So decarburization is again a very important and critical criteria, because it totally will affect the end use and the application at say a wheel bolt, for example, the one which is fit on the bolt. If that is made out of decarburized wire, heavily decarburized wire, there is a very high chance that the wheel bolt will just open up on the road while driving, because the carbon hardness has come down, and it will lose its strength. Okay, so that's decarburization. Third parameter we look at is tensile strength. So tensile strength is the maximum strength while being stretched before breaking. Okay, so it's the most fundamental property that we record when we take a requirement, or the customer gives when he wants to place an order and inquire. So it's the most fundamental category. This tensile strength is the parameter for defining strength and durability of a wire. So it can go both the ways. So if the wire is too hard, it can lead to breakages. If the wire is too soft, maybe it will not be able to take the desired shape, or maybe you will make a product which is not very accurate in measurements. So this is number three. I feel like if you can get it, you can fit it in a range, but you have to get it right. And this will change according to the composition and the process that you've done on the wire. Okay. Fourth and the foremost criteria, which I think is very, very important for cold forging, is yield strength. That is the amount of stress a metal piece of metal or wire can withstand without understanding permanent deformation. Okay, so when you're trying to stretch a wire, it will stretch, and there is a point where the shape will change. Okay, so that is yield strength. So yield strength is basically the one which will provide you on the basis of which you can have designs your tool, you can control your process, you can determine the efficiency at forging level. So I think a lot of people, lot of fastener manufacturers focus on yield strength, tensile strength, and don't focus so much on yield strength. So I think over a period of years, after so much interaction with customers and attending complaints of all sorts and examination, you understand these nuances. Only then all these also can matter. Another, I mean, all of them are important, but another important criteria I feel is the elongation. Elongation refers to the material's ability to stretch without breaking. Okay, all these are like very overlapping, but I think there are like minor nuances which will affect the performance of the material on the machine and post machining also. Okay, so with better elongation, you can get better formability and less cracks at cold forging. So when you're running a machine, the idea is that you want the machine to run non-stop without breaking, without stopping. That's the ideal way anybody wants to cold forge, if you have sufficient orders, obviously. But I wish sufficient orders for everybody, and that's the way that these four parameters will sort of play there. If you pick the right material, which has a good mix of all these parameters, you will get the desired result. And the last and the foremost we feel is surface finish. Surface finish will determine your tool life, how the material is acting, how are you able to store the material before and after forging, and the life shelf life of material is basically, I think, surface finish, and how smoothly the machine material is running on the machine, how smoothly is, operators also don't want hassle while running the machine, right? And these are the 5 6 parameters that I think are very critical in selecting the right CHQ wire for code forging and fastener making.
So, Dhruv, while we're talking to you, there are audience questions as well that we will go on addressing as we speak and converse. So, there's one question that we have in the past received from one of our audience, which is about the benefits of using coated wires in fastener making.
Okay, this one is my favorite, I think. We've all we so we get very cost conscious customers who are like, why should I get these coated wires and everything? And my only question to them is, what machines are you using right now? So India is not a place anymore where people are scared to do heavy capex in very high quality imported machines, right? Matlab, you see everywhere in fastener technology, I think people are getting machines from Taiwan, China, Europe. So I think that's the commonplace right now. And people want to invest in good machines, and they want to run a business for a lifetime, and they want to run like hassle-free good business, fastener making. And when you get such machines, okay, the second thing is, what is the input are we talking about? You get the best machines, but if you don't put the right food in the machine, how are the machines going to perform? And that's my second thing when I say, like, if you want the production that your Chinese and Taiwanese are able to get on their machines, you have to look at the raw material also. The kind of raw material that we get by default in Taiwan is way superior than the ones that we get in the average material that we get in India, and the average fastener maker is using right now. So when I'm talking about coated wires, you need for the machines to run flawlessly, and to get a very high level of accuracy and quality in production, you need very standardized and uniform wire. Wires and surface finish on the wire is like the most baseline criteria. It's the first thing that's gonna touch your tools. It's the first point of contact between the wire and your machines. Okay, and you have to find ways, what is causing friction, what is lowering the vibrations in your machines. How can I, if the wire is lying at my place for certain days, how can I improve its shelf life? Because if the wire starts rusting before it's put to use, then it will create problem at cold forging stage. If the product is made and if it's not coated or it's not polished timely, again the coating plays a very big role. So I think if I want to summarize why you should use coated wires is efficiency, high production, low cost, and shelf life. These are the 4 things that I would like to say. Like, if any fastener or cold forging company is looking to look at these areas, then they have to look at coated wires, and wires which are coated with a very uniform coating, and not a shoddy job in coating.
Correct. And Dhruv, how do tolerance levels impact the quality and consistency of fastener products?
Okay, so the role of quality equipment at wire making will help you determine. For example, say I will give you an example of heat treatment. So we have a certain heat treatment equipment which is very expensive and highly sophisticated. The whole idea is we want very narrower bands of tolerance, very tight tolerances we want in the output that we get. So we essentially, what we are saying is, we want very uniform and consistent result. So the result that I get in the first 5 feet of the wire rod coil is what I want in the end and in between also. Okay, so quality equipment at wire making stage will ensure the tolerances are narrow, and narrower tolerances will mean better production quality and cost. Okay, and also you can get more confidence in terms of the accuracy that you want in the final product. The final product, if you are Now, tolerances are very narrow. You will get a final product which is very tied to your accuracy of your dimensions of your final product.
Right. Right. While we were discussing the tolerance levels, Dhruv, there is another question which is to do with the examples or instances which you could share with our audience in terms of where investing in higher quality wire yields has given significant benefit in the manufacturing process.
Okay, so there were two instances. So one, I will talk about coated wires only,
Yeah.
because so one is so as fastener manufacturers, the working capital cycle is very long. So you're buying the raw material now, you're storing it at your end, then you're doing production, then there is a dispatch, and then there is storage at the end of last warehouse for just in time for customer. So not all the products are galvanized or coated. Some products are, some products are not. So in one case we realized like the customer was insisting on a very high quality of phosphating and very consistent phosphating, and upon digging it further we realized that he's almost storing the product for like 6 months. And I was surprised, like even after machining and going through so many processes, the last appearance, matlab after 6 months also the appearance did not change. So that is one area where I felt like if you are using very high quality coating, or the wires are very made in a very tight manner, you will get the life of the product. Second instance was my customer was complaining about low tool life for a certain line of product, and I suggested that he was getting this done from somewhere else, and I suggested, why don't you try our wires? But there was always a discussion regarding, oh, I'm not going to be able to afford your cost, your rates are too much, and things like that. And I was like, okay, fine, let's just do this experiment. If it doesn't work for you, then it's on me. Okay, and we supplied a very small lot of like 30-40 tons, and he bought the same wire from somewhere else. We both were essentially using the same wire rod, and just think of it that one was made at my location, other was not made at my location, and there was a difference of 20 to 30% in tool life between the two.
Because this sort of re-emphasizes on the fact that we are using quality products. My next question is about quality. So what methods are used to ensure the quality of the wire before and after cold forging?
So I'll walk you through our process of what we do and how we focus a lot on technical validation. So when we get a requirement, when the customer comes to us, we want to see what the end product is making, what grade is he asking, are these properties be achievable in the grade he's asking and suited for the end use. And on that basis we look at wire rod selection. So wire rod selection, we use our view, we use the raw steel mills view also. If these properties can be achieved or not. If we think this sort of risky, we try to place a special order. We do that very often for a lot of our clients. Because they're very particular about certain characteristics or property of the wire, and we place a special order just to make sure that issue is not repeating again. On that basis, we buy wire rods. After buying wire rods, where I think we differentiate is we do a lot of pre-surface preparation. So pre-preparation of the surface, I would say, using our in-house technology like pickling, phosphating, drawing, and various descaling processes. So we use multiple combination of these processes where we prepare the surface for the next step. So when we receive the material, it's not in the best shape and condition, and to get a very good result out of it, you need to do very religious surface preparation so that your desired output is good. This also includes our incoming quality process, where we use microscopes, spectrometer, tensile testing, and all these. And on the heart of our factory is the heat treatment furnace by Ebner, Austria. They're one of the best technologies in heat treatment right now. And we've also used other equipment for heat treatment, but I feel like um, I feel you get certain desired level of output and very consistent, very consistent results that we've got time and again. And it's just not about the product. Also, I feel the way the furnace is highly automated and very sophisticated, and there is no bit of manual intervention involved for for the results to differ or vary. And we've got such fantastic results, and we totally believe in this technology, and that is why we've also installed one more furnace right now, and we just inaugurated it last month. So uh, these are the things that we do at our end, and with very thorough inward QC and outward QC. We have our in-house lab which runs through various processes, and then again we're trying to build a analytics and data wing, which wants to work more on data to remove defeats.
True, because you were talking about QC, which is quality control for the audience. How important, according to you, is QC measures in fastener manufacturing to meet the industry standards and customer requirements?
So, wire making and fastener making. So, I've spoken about wire making. Now I'll talk about fastener making on based on my understanding of customer interaction. So, fastener making is, the top tier of fastener consumers are automotive clients, and automotive clients means you are working at the safety is at the helm of it. The wire or the steering wheel cannot be just coming out, right? So it's very critical to understand that there is human life involved if the products don't meet a certain criteria. Okay. And that and I'm so fortunate, I feel like the automotive supply chain also works on supplier rating, performance, and very strict control. Okay. So I think there is no doubt that as a fastener manufacturer you have to supply quality products if you want to work with the best. But certain things that we've seen and we strongly suggest our clients to do is, at RM stage, we want them also to verify grades using a spectrometer. A lot of them, microscope, spectro, and we want them to run all these tests. And very good facilities have in-house functions, which do this on a very regular basis. Okay. Second element, we feel like a lot of times small and mid factories, they don't have in-house heat treatment or plating. Okay. And the moment you outsource is you sort of lose control over the desired outcome or how it is maintained. And heat treatment is about like maintaining more than 200 checkpoints every time you do run a cycle. Okay. So I think another point would be to see if this can be done in-house or is outsourced to a very high quality person who does specializes in fastener heat treatment and plating. A lot of times, whenever there is a automotive, whenever there is a recall by a or top automobile company, there is always an emphasis on traceability. Are we able to trace back to the raw material? So often at times we get involved in providing our samples and things like that. So at fastener manufacturing, you have to ensure that you are maintaining traceability and lots, and so that that sort of monitoring is easy in case a defect arises or in case a recall arises, because it will put you as a supplier in question. Okay. um, what we do and what our clients also do very religiously is calibration of all the quality production and heat treatment equipment. So even heat treatment equipment, you have to make sure that they're being calibrated time and again. And uh, uh, faster manufacturing is moving to very use of highly sophisticated equipments like optical sorting, which does sorting of quality on dimensions at a very fast scale. So I think these are some of the measures that I think faster manufacturers are adopting and moving very fast when it comes to quality measurement.
Understood. So there was a question that we were asked in one of our episodes. If I fairly remember, it was episode 26, where one of our attendees asked this question as to how to MSMEs, particularly in your sector or area of interest, cope with shortage of raw materials?
So I think my only thing is, you have to work with, you have to have very close relationship with mills. So everybody wants consistent business, and you have to be consistent to your suppliers. Okay, be it be it any stockist or raw material mill. You have to be very consistent, and I think it's not fair to say that raw material mills don't take small orders or something like that. I think they're looking for a very very consistent and regular customer. I think everybody wants that, right? You want a consistent this. And second is, you have to work with a team of raw material sources. Just can't depend on one. And it's a permutation and combination based on what your customer is asking, and how how you envision material movement and inventory. Based on that, you have to work with 2 3 or 4 or maybe 5 6 mills and a combination of stockists.
Could you, Dhruv, also share with our attendees a couple of lessons that you may have learned while you were progressing in your career, and some of the best practices from case studies that you may have experienced?
Every day it's like a lot of learning about team management, I feel. And then yeah, a couple of things that stood out to me. One is, like, quality. No matter quality never will go out of fashion. If you are in the business of quality, I think over a period of time you will stand out. And people say that steel is a volume business, but I think it is what you look at. Niche businesses will give you better margins, and could give you better margins if operated efficiently. So in any business, I think you can look at very large volume business that is also could be losing money, and very niche business maybe making the same amount of money as this. So I think it depends upon where you're looking at. And I think you have to take your people along as you go on the journey. They will also evolve. I think that's one thing that I've learned. Like, you have to take your team along, and nobody comes in trained. Like, everybody learns on the job, just like the CEO also. So so I'm also learning on the job. I feel like work in progress. And every day when I go to the factory or the office or I meet a client, I get to know so much, and it's overwhelming at times. But I think it's a part of the journey. I think you learn to enjoy it over a period of time.
That's absolutely right. With that, I want to ask you one last question, which is to do with what is the future of this industry as per you?
I think if you ask me, future in India looks very very bright, because we see infra, automotive, machining, capex, everything is growing at a tremendously large scale. So I think India has a lot of opportunity. I think the question is, if you can truly establish factories which can, which the world can look at and say, oh, this is an equivalent to a Taiwanese company or a Chinese manufacturer, and manufacturing out large volumes of very high quality products and consistent products. I think that's the key. I think that's where I look at saying key, if I can I do that, like and I think there is no dearth of opportunities, no matter in any sector that you touch in India at the moment, I think. So yeah, and when I look at steel and fastener making, I think number of companies are large, but companies which are manufacturing quality are smaller, fewer in number. And also with in the fastener business, I think we have some regulations regarding restricting some imports from China. I think that opens a very large opportunity for people in India right now. So it's a massive growing market, and there is a huge gap in the market right now, which is waiting to be fulfilled.
That's lovely. We do understand that the future seems extremely bright with regards to fastener making and cold forging. Dhruv, one last bit that I would like our audience to sort of understand is the fact that I'm sure there are a lot of government schemes that are sort of, helping or boosting the sector for you guys at this scale, at this stage. Sorry. Would you know any of these, and would you want to like share a couple of these which you've benefited from or the companies benefited from?
So I think that's one area where the country can still improve on. I think. I think they had a very large incentive plan for investment more than 100 crores, but I don't think majority of us lie there. Okay, so other than that, there are like the state incentive schemes which vary from state to state, and I think a lot of people are already availing that. And then there are some incentives on employing new and fresh people into bringing them into mainstream. I think there is some PF incentive that we are utilizing sort of that. I think these are the only two schemes that we are able to get benefit on as of now.
Got it. So, in today's episode, we've captured the nitty-gritty of cold forging and fastener making, and with that, we've reached the end of the episode. I'd like to thank you, Dhruv, for sharing your in-depth insights and your lovely examples with our attendees. It's actually been an honor to have you with us on this episode. So, thank you so much, Dhruv.
Thank you so much, and I hope to be back soon again with some fresher insights. And I hope I did justice to your time, to the audience's time with whatever little I knew. Thank you.
Absolutely, absolutely. For our audience, look for JSW MSME, JSW1 MSME on YouTube and check out our recorded MSME Masterclass videos, including this one. You'll find all of them on our YouTube channel. These episodes can help you gain market intel and improve your future readiness in MSMEs. So, thank you once again, Dhruv. Lovely having you.
Thank you so much. Thank you.